Industry reports say that 41 key regulations will roll out between 2025 and 2030. 4 of them will hit IoT companies hard.
I hear CE certification all the time. What's that about?
We split them into 2 categories, mandatory and voluntary. CE certification, total mandatory. It's split by market. CE is for the EU, FCC for the US, CCC for China.
With multiple operators in some countries, how do makers choose which certifications to get?
They need to weigh 4 big things: target market, technical requirements, certification process, and cost.
Hey there, dear listeners. Welcome back to IoT Simple Bites, your go-to podcast from SIMCom all about the IoT and communications industry. I'm your host, Mia. Today, we're thrilled to have David from SIMCom's GTM team join us again to dive deep into IoT topics. David, say hi to our audience.
Hello, Mia, and hello, everyone. Great to be back on IoT Simple Bites. I'm already pumped to jump into today's chat.
Awesome. Let's cut to the chase. Our topic today is the non-negotiable steps for IoT devices breaking into Europe. Lately, there's been a big headline making waves in the industry. Starting August 1st, 2025, a new EU cybersecurity regulation will become mandatory. David, can you first break down what this new rule actually means?
Absolutely, Mia. This regulation stems from the EU's EN 18031 standard series, released in August 2024 to assess cybersecurity requirements for the Radio Equipment Directive, RED. It was added to the RED's Harmonized Standards list on January 30th, 2025, and officially takes effect on August 1st, 2025. Put simply, it sets the bar for radio equipment to meet the EU's cybersecurity mandates. With IoT exploding, tons of wireless IoT devices, think smart cameras, smart speakers, wearables, POS machines, are connecting to networks.
These devices really make our lives easier.
But they also bring security risks.
Oh, really? I had no idea using these devices could pose security risks.
Most people aren't aware of this, so the new regulation matters a lot. It makes sure these internet-connected radio devices, which handle personal data, have built-in protections from day one of design.
No more unauthorized access.
And no more personal info leaks, no more sketchy business with money transfers. You get the idea.
That sounds crucial. What specific demands does it put on devices?
It has rules tailored to different risk levels, covering every step of a device's lifecycle. Take devices that connect to networks on their own, like smart thermostats. They need a security chip baked in during design, so if someone hacks them, they can't send bad commands that mess up the whole network. Then, during production, each device gets a unique security key. No two are the same, so we always know which device is which. For gadgets that handle personal or location data, like smartwatches, end-to-end encryption is non-negotiable as soon as data is collected. Storing that data? Got to use encrypted storage, so no one snatches it off the device itself. And to get in, multi-factor auth is a must. Fingerprint plus password, for example.
And let's not forget retail payment devices. I always have concerns about security whenever I make a payment.
Smart POS machines, right?
Yeah.
When verifying transactions, they need extra checks. Not just a password, but a digital signature too. Sending payment data? Only over a dedicated encrypted channel. No interception allowed. Even maintenance needs strict permission controls, so repair folks can't sneak a peek at payment info. It's like a security blanket for every stage, from design to daily use.
Mobile payments are becoming more and more popular these days. When I traveled to China before, people there didn't even need to carry cash when going out. They could pay with their phones for absolutely everything, like taking the subway, eating out, or shopping. So what you just said is a big deal for the entire IoT industry, especially for device manufacturers. David, could you hurry up and break this down for us?
Sure. For consumers, total win. Their security and privacy get way better protection.
But for IoT device makers,
It means shelling out more cash and putting in more work to meet these standards. R&D teams have to redo design reviews, swap in safer tech and parts. Production lines need tighter quality checks to hit the new rules. Even after sales, they need a solid plan to fix security holes fast. And if they don't comply, ouch. Products get pulled from shelves, fines hit hard, up to 4% of annual revenue, or customs seizes shipments. Not a fun day at the office.
With rules this strict, non-EU IoT makers must be sweating.
You bet. Before this, some non-EU makers didn't take EU cybersecurity standards seriously. They design and build for their home markets or other regions, not the EU. Let's say a company makes smart door locks. They might only follow their local security rules, use basic encryption like AES 128, and just slap a quick encryption layer on data before sending it. Back then, the EU's rules weren't this tight, so it flew.
But now, if they want into the EU,
They've got to flip their whole design mindset. That smart lock maker, they need to step up identity security. Use AES 256 encryption, way stronger, for passwords and data. Supply chains get stricter too. The CRA, Cybersecurity Resilience Act, has tough rules for supply chain security. Makers have to vet suppliers super carefully, check that third-party parts are safe, and do their homework on every component. No more picking suppliers at random. They're on the hook if a bad part causes a security breach.
that seems to impose stricter requirements on manufacturers across their entire production workflows and cost management. How about certifications?
They need to plan ahead, learn exactly what the EU wants, prep all the paperwork, run the right tests, no cutting corners. And after sales, a solid response system is non-negotiable. If a security hole pops up, they've got to fix it fast and tell users about it, per the new rules.
Definitely not an easy job. Looks like the new regulations' impact is no joke. SIMCom's modules, do they meet this new standard?
We saw this coming back in early 2022 when we heard Red would add cybersecurity rules. So we got a head start. When EN 18031 dropped in August 2024, laying out the nitty-gritty for RED's cybersecurity clauses, and leading up to the August 1st, 2025 mandate, we already finished certifying most of our modules for the EU market. And we've got the test reports to prove it.
SIMCom's always one step ahead. Great news for your clients. And I'm curious, beyond EN 18031, what other key EU rules do IoT device makers need to watch for?
Great question. Industry reports say that 41 key regulations will roll out between 2025 and 2030. 4 of them will hit IoT companies hard. The one we talked about, the Cybersecurity Resilience Act, CRA, the Data Act, the AI Act, and the Corporate Sustainability Reporting Directive, CSRD.
That's more than I expected. Let's focus on the IoT industry instead. David, spill the details. Everyone's dying to know.
Let me break this down for everyone. All 4 are core EU laws for digital governance and sustainability. Let's start with the CRA. It covers anyone making, importing, or selling products with digital elements, PDEs, in the EU. Makers have to follow strict cybersecurity rules, and they've got super tight deadlines to report incidents. The cost to comply is huge, and the fines for breaking the rules, even bigger.
I think the CRA is expected to set extremely rigorous demands for supply chain security management.
Brutal, but necessary. Makers don't just have to make sure products have no known bugs when shipped, they also have to do due diligence on third-party parts they use, and take responsibility if those parts are unsafe.
Things are getting complicated. Let's take an example to explain this.
Let's take a smart fridge, for example. The maker has to check the security credentials of every supplier for its sensors, chips, whatever. They need safety test reports for each part. If a bad chip causes a security hole in the fridge maker is on the hook. There are also detailed rules for cybersecurity risk assessments, fixing and disclosing vulnerabilities, and reporting incidents. If a smart fridge has a bug, the maker has to post a vulnerability notice within 72 hours and have a fix ready within a month.
Oh, as a consumer, I love hearing this.
Feels safer, right?
Totally. What about the Data Act?
It sets legally binding rules for data sharing, access rights, and cloud services. Makers of connected products have to let users access their product data. Businesses sharing data, they need to follow the same rules. And cloud providers, no more charging crazy fees when a customer wants to switch to another provider.
That makes so much sense. David, AI is everywhere these days. Let's talk about the AI Act.
The EU AI Act is the world's first comprehensive law regulating AI. It uses a risk-based system to spell out who does what. High-risk AI systems like medical AI or hiring AI need strict assessments and have to be registered in the EU. They also have to meet data quality standards and require human oversight. Generative AI, it has to label its outputs. And some AI uses are totally banned, like social scoring systems.
I think AI has already made a huge impact across every industry. The changes it's bringing have also stirred up a lot of debate, and we truly need to tighten up the relevant regulations ASAP. So, what happens if you break this?
Fines, up to 6% of global revenue. Ouch.
Gotta have teeth to keep people in line.
Exactly. Last up, the CSRD. It's the EU's core law for ESG, environmental, social, governance reporting. It replaces the old mix of voluntary and mandatory rules with full-on mandatory reporting for eligible companies. Businesses have to disclose their ESG strategies, risks, and performance using unified standards. And an independent auditor has to check if the report is true. ESG is all about measuring a company's sustainability, and global rules are getting tougher on ESG duties and reporting. The CSRD started rolling out in 2024 and will cover all eligible companies by 2029.
These rules really tie everything together. David, besides AI, I think 5G is still a big focus. Are there EU rules for 5G?
You bet. The EU's 5G compliance guidelines. They lay out detailed demands for 5G device performance, security, and interoperability. Take 5G gateways for industrial control. They need to fend off advanced persistent threats, APTs. That means building antivirus and anti-intrusion tools right into the device's OS. And 5G devices from different makers, they have to work together seamlessly to keep the 5G network running smoothly. That means strict adherence to unified communication protocols, no exceptions.
Well, I hear CE certification all the time. What's that about?
To answer your question, let's start with the basics. IoT certification systems are complicated and vary by region, but their main goal is simple. Make sure devices meet local rules for security, electromagnetic compatibility, wireless compliance, and energy efficiency. We split them into two categories, mandatory and voluntary. CE certification, total mandatory. It's split by market. CE is for the EU, FCC for the US, ISED for Canada.
CCC for China?
Yeah, all mandatory. When IoT product managers plan a device, they need to map out which mandatory certifications they need for their target markets.
So CE is the golden ticket to the EU market, a mandatory entry requirement.
Precisely. For IoT devices, which usually have electrical and wireless features and are used by consumers or businesses, CE covers safety, health, and environmental protection. To get it, you must meet three core directives: LVD, Low Voltage Directive, EMC, Electromagnetic Compatibility Directive, and RED, Radio Equipment Directive. And remember EN 18031 we talked about? That falls under the RED.
That clears things up. But I've never heard of LVD. As for EMC, I know it's related to electromagnetic issues. And I've heard of RED quite often. Can you walk us through each directive?
Okay, let's start with LVD. It's all about electrical safety, keeping people safe from harm. It applies to electrical devices that use 50 to 1000 volts AC or 75 to 1500 volts DC. It forces makers to follow safety standards to prevent shocks, fires, overheating, or other risks from faulty electrical design. Nearly every IoT device that needs power falls under this.
Everyone knows you can't cut corners on standards related to personal safety. We hear about fires from electrical problems in the news all the time. Ones that result in lots of property loss, even deaths. It's truly devastating. And we definitely need to establish rules to keep everyone safe.
Absolutely. Let's take a home smart camera, for example. LVD requires its power adapter to have overvoltage and short circuit protection. The case has to be made of flame retardant material. No shocks when you plug it in. No fires if it shorts out.
You know what? I get really scared every time I see sparks when plugging in or pulling out a plug. That's why I fully support the strict enforcement of this directive.
I totally get it. And here is another example. Smart plugs. LVD demands their internal metal contacts can handle the right current, last through lots of plugging, unplugging, and pass a shock test, so a kid's finger can't reach the live parts inside.
Lives are on the line here.
Exactly. For users, LVD stops IoT devices from hurting or killing people, or burning down houses, because of shoddy electrical design, like cheap adapters or bad insulation.
And for the market?
For the market, it unifies electrical safety standards across the EU. No more Germany wants this, France wants that for smart plugs. One standard, one playing field.
That's really a good example. Let's move to EMC.
EMC is all about solving electromagnetic interference, EMI, so devices play nice with their environment. It forces devices to do two things well. First, electromagnetic susceptibility, EMS. The device has to work normally in a noisy electromagnetic environment, no matter what other gadgets throw at it. Second, electromagnetic emission, EMI. The device itself can't emit so much electromagnetic radiation that it messes up other devices nearby.
I think this stuff gets tricky. Let's use some real examples, David.
Fair enough. Take a Bluetooth temperature humidity sensor, the kind you might put in an office. It's surrounded by computers, routers, AC units. EMC says, the sensor's radiation can't mess up the Wi-Fi router. No more, why is my internet lagging? And the sensor has to handle the AC's electromagnetic noise. No glitches in its readings, no dropping off the network.
I never thought my office Wi-Fi issues could be from a tiny sensor.
Oh, trust me, it happens. Another example, smart door locks. EMI says the lock's motor circuit can't interfere with your neighbor's TV signal. EMS says even when the microwave's cranking, total electromagnetic chaos, the lock still works. You can scan your fingerprint or type your code. No locked out in the rain disasters.
The last thing I need is being stuck outside because my lock freaked out from the microwave.
Right? Imagine a smart camera that disconnects every time the router acts up, or a smart speaker that goes silent when the microwave runs. Those products are useless. Worse, if IoT devices emit unchecked radiation, they could mess with critical gear like medical equipment or traffic signals. That's a safety nightmare.
This is a big deal. You don't even want to think about the consequences.
Yeah, so the EU has strict emission limits for different scenarios: homes, factories, hospitals. EMC keeps the public electromagnetic environment in order.
They're definitely doing the right thing. I've got a question here. Do all these mandatory certifications have anything in common?
Three big things. First, they're all based on national or regional laws. They have legal teeth. Second, they use a certification list to define which products need them. Only products on the list require mandatory certification. Third, you need a third-party lab approved by the authorities to test your device. Pass and you get a certificate. Some devices even need factory inspections like CCC's post-certification checks.
Thank you, David. You've made this clear. Then let's wrap up with RED.
RED regulates wireless communication to keep the radio spectrum in order and make sure wireless connections are safe. It applies to any device with wireless transmitters or receivers. Think Bluetooth, Wi-Fi, 4G/5G, LoRa. It covers spectrum use, communication performance, EMC, and safety. Let's use a 4G smart water meter as an example. You know what those do, right?
Easy. They send water usage data to the utility company over 4G.
Nice. You really impressed me. RED says that meter has to use EU-approved 4G bands, like band 3, 7, or 20. No sneaking into unapproved bands like aviation frequencies. That would crash public communication networks. Performance-wise, The data has to upload reliably, with a stable signal. The utility needs accurate readings. No billing errors because the meter's connection dropped.
And data security?
Big time. The wireless signal has to be encrypted, using TLS, for example. No hackers tampering with the data, like, oops, my water usage magically dropped to 0.
I didn't realize hackers would bother with water meters.
They will, if there's a loophole. Let's take another example. Do you know LoRaWAN's smart smoke alarm?
I definitely know that. They're all over the place, in commercial office buildings, public areas, everywhere.
Yes. It sends alerts to the property manager over LoRa. RED says it has to use the EU's approved LoRa-free bands, and its transmission power can't be too high. No blocking other LoRa devices nearby. The alarm's wireless module has to meet EMC rules. RED covers some EMC, so no double testing, but it still needs to be compatible. And the alert has to reach the manager fast. Delay under 10 seconds max. No waiting around while a fire spreads.
I know radio spectrum is super limited.
Exactly. RED stops IoT devices from hogging or crashing the spectrum by regulating bands, power, and how signals are sent. Wireless IoT devices often handle sensitive data, water bills, smoke alerts, security feeds. RED's rules for encryption and reliability keep that data safe and stop devices from failing when it matters most.
I've heard horror stories about smoke alarms failing to send alerts because of bad wireless. Total nightmare.
So that's the importance of communication quality right there. For makers and users alike, CE is way more than a sticker. It's about market access, brand trust, compliance costs, and safety. Those 3 directives, LVD, EMC, RED, are the EU's bottom line for IoT devices. Passing them means your device is safe, compatible, and communicates reliably. Your key to the EU market, and your promise to users that you've got their backs.
Is getting these certifications expensive?
It depends on the product, the cert body, and the tests you need, but usually between €350 and €18,000. Wireless devices need RED testing. Starts around €600, but gets over €1,200 for complex multiband gear. Medical devices? Way pricier, usually over €2,000, sometimes even 6 figures. Devices that only need EMC testing are cheaper. Add LVD electrical safety testing, and the cost jumps. And if you go with a big-name cert body like TUV or SGS, they charge 40% more than smaller labs, but their seal of approval carries more weight in the market.
That's a big chunk of change for makers.
Don't forget the extras. Technical document writing/translation, fees for an EU-authorized representative, shipping samples or rushing tests, all add up.
With the economy tight, I feel for these companies. Does SIMCom certify all its modules?
For CE, we focus on the RED directive, since that's what matters most for our modules. Any module going to the EU gets RED certified. That saves our clients a ton. Less money on their own certifications, less time waiting, so they can launch their products faster and grab market share. Here's the thing. IoT devices often use pre-certified wireless modules. That lets the whole device skip some RED steps, called module certification exemption, but it still needs to meet EMC, safety, and energy efficiency rules. That's why our Cat 1 module, the SIM7672E, is blowing up in Europe's tracker market. Our NB module, the Y7080E, is everywhere in European emergency lights. And our 5G module, the SIM8262E, perfect for CPE and MiFi makers.
That's a huge help for your clients. Quick question. RoHS certification, is that mandatory too?
Absolutely. RoHS regulates the materials and manufacturing processes of electrical or electronic products to protect human health and the environment. If you want to sell an electrical or electronic product in the EU, you must pass RoHS testing, no exceptions.
Got it. Are there any other mandatory certifications we haven't covered?
Operator certifications are mandatory in a way. Take China, for example. Without China's CTA certification, you can't sell or use a product there. In Europe, operators like Vodafone and TIM have extra tests for things like SAR, OTA, performance, and audio quality. They call these KPI tests. They're not legally mandatory, not part of EU laws, but if you want your device to connect to their networks, you have to pass them. So from a market access angle, they might as well be mandatory.
With multiple operators in some countries, how do makers choose which certifications to get?
They need to weigh 4 big things: target market, technical requirements, certification process, and cost. Take Deutsche Telekom. Their network performance and security tests are strict, but if you pass, your device works in all the European countries Deutsche Telekom covers. Plus, some operators offer perks for certified devices, like listing your product in their recommended catalog. It's free marketing. Deutsche Telekom, for example, gives certified devices a leg up in their European markets.
That's nice. It's like a value-added service. Let's switch to voluntary certifications. What are those?
Voluntary certifications aren't required by law. Makers can choose to get them based on market demand, client requests, or their brand strategy. The goal? Prove your product stands out, whether that's better performance, stronger security, better compatibility, or higher energy efficiency. It builds trust with customers.
So they're like bonus points for market competitiveness. It's like how graduates get more skill certificates. They help sell themselves better.
Exactly. Makers pick them based on their target audience or market needs to add differentiation. For Europe, wireless devices must pass RED, but a maker can voluntarily get GS certification, a German safety standard, to boost trust. GS is super respected in Europe. It's like a German seal of quality. Great for high-end consumer IoT gear. Think smart home appliances or wearables.
If I were in charge, I'd try my best to get these certifications to boost the product's competitiveness as long as the budget allows. After all, you can't make an omelet without breaking eggs. Well, any other voluntary certifications worth knowing about?
Ever heard of EPEAT?
Yeah, it's come up a couple of times, but I don't know much about it.
It's run by the Green Electronics Council and focuses on a product's environmental impact across its whole life cycle: design, production, recycling. Governments and big companies prioritize EPEAT certified products when buying, so it's a no-brainer for IoT makers targeting enterprise or government clients, like those making industrial tablets or smart surveillance gear. Then there's GDPR-compliance certification. It proves your device handles data in line with the EU's General Data Protection Regulation, which cuts down on privacy risks. Perfect for IoT devices that collect user data in the EU, like wearable health trackers or smart home cameras.
Let me make sure I get this right. Mandatory certifications are the floor. They let you sell your product in a market. Voluntary ones are extras. They help you sell better. Makers pick voluntary ones based on their target market, clients, or brand.
You nailed it. For IoT companies going global, the sweet spot is a mix. Mandatory certifications to stay compliant, plus key voluntary ones to stand out. It keeps you legal and competitive.
So, to recap, we started with the EU's mandatory EN 18031 cybersecurity rules, talked about other key EU regulations rolling out, broke down mandatory versus voluntary certifications, and even covered how to save money and time on certifications.
Yep, we packed a lot in today.
It's clear IoT devices face a lot of policy and certification hurdles to enter the EU. David, thanks so much for your awesome insights.
My pleasure.
That's a wrap for today's episode of IoT Simple Bites. Thanks for listening, everyone. We'll see you next time.
See you.